Nathalie Cabrol is an alien hunter. She's a planetary scientist at the SETI Institute and the director of the Carl Sagan Center, where she searches for signs of microbial life on Mars. Now, she believes humans will live on Mars one day. Her research in the high Andes led to the discovery of a world record UV index of 43, which is more similar to the surface radiation on the red planet than here on Earth. Now, the recipient of numerous NASA and other research awards, she's also earned the nickname Mrs. Gusev for choosing to land the Mars Spirit rover at the Gusev crater in hopes of finding water. Recently, NASA confirmed her hunch and announced the discovery. Nathalie Cabrol joins me now on Full Frame. Great to have you here, Nathalie.
Good morning.
And talk about some great achievements on your part. That's pretty amazing that you actually were the one to discover that there was water at the Gusev.
Well, it's a long story. You know, the water was there a long time ago.
Right.
So it's not that we discovered the bucket of water sitting at the, at the surface of Mars. It's the sign that water was there and abundant in the past, which is really, really interesting when you are looking for signs of life.
But that must have been pretty gratifying for you when you found out you were right.
Well, you know, science is not about being right or wrong. It's about learning. And so, of course, it's gratifying when, you know, your hunch is confirmed.
Right.
But I guess that more importantly, it was a team effort. What was very gratifying, on the other hand, was to have spent nearly 10 years, you know, just looking at pictures, orbiter pictures, and from the top, from very high, at the Viking images. And one night, just having a panorama of that place that you have been looking at for so long and from so high. And the first panorama, you know, at Gusev definitely is engraved right here.
Wow. Well, your current project right now at the SETI Institute, it's all about exploring past life on Mars, right? Tell me about what you're finding and, you know, what you're learning.
Well, as you can see with the series of missions that we've had, 10 years ago, we sent a first orbiter to take images of Mars, and we learned about the geology. And there we wanted to understand, was Mars active? Was there water out there? What kind of information the mineralogy is telling us? And then there was another orbiter, and that one told us about climate, past climate and current climate. Was the climate favorable for, you know, the presence of water, for instance? So we learned a little bit more. And then once you had the geology and the climate, then you start having the data that is necessary to think about habitat and life potential.
Right.
And so we started preparing a mission, and that was the Mars Exploration Rover mission, to land on two places where we thought that water had been abundant for a long time on Mars. And so that was Meridiani and Gusev. And then, yeah, it was confirmed that Mars was habitable a long time ago. And now we're going, you know, we continue on this march, as you said, you know, science takes time.
Yeah.
And that's the difference between the reality TV shows and real, you know, having to gather the data, but also to chew on it and understand what they really mean. And so today we've had the Mars Exploration Rover. One of them is still continuing on. We have Curiosity. The ExoMars, ESA ExoMars mission is ready to go in a few days. In 2020, the Mars 2020 mission is going to leave, and for the first time in a very long time, we are going to search for life on Mars. We never actually looked for life on Mars.
Really?
One time with the Viking mission in '76, and I think this is where the disconnect is with many people, is that people think that we have been looking for life on Mars for 40 years.
I thought so.
We haven't.
Really?
No, the first one and the only one that did actually was the Viking mission. And that was the first that landed on Mars in '76. And it had an experiment, but at the time we didn't know anything about the environment of Mars. And so the result of that mission were very much debated, still are today. But starting with ExoMars and with Mars 2020, we are going to seriously look at the potential for what we call biosignatures, the signature of life on Mars.
Well, then let me ask you now, Nathalie, because you've done so much research of microbial life, right? Isn't that a sign that there was or is some kind of life there?
It's, you know, let's say that the environment was favorable to life as we know it.
Okay.
And then when I say as we know it, it's microbial life. You know that Mars is a pretty harsh desert, and you have lots of UV environment.
Yeah.
Lots of UV on it. And so anything at the surface will be pretty much fried.
Yeah.
You know, and very, very
you
fast.
get a serious suntan on Mars.
Yeah, the kind you never recover from.
Right.
But let's say that if things happen the way they did on Earth, and because we had a similar environment at the time on Mars, the bricks of life that we know on Earth are present on Mars. That doesn't mean that, you know, 2 equal 2, but it might. And
so you're saying the start
is
very
the same.
similar.
Very similar. The two planets have, you know, the only difference is Mars is and was always farther away from the sun.
Right.
But at the time, we have evidence that Mars could have been, you know, like the Arctic on Earth. So, you know, there is a room for biochemistry with that. And so, to me, what's more fascinating about the idea is that at that time, too, the Earth and Mars were still exchanging a lot of material. And the two planets being formed.
What do you mean exchanging?
Yeah, well, so what happens when a planet forms, you know, at the time, it's by accretion of dust and rocks, and then bigger, you know, bigger bodies, comets and asteroids. And so accretion means that they are coming together and the clumps become bigger, and then you're getting a planetoid and a planet. And as this happens, you think that you have lots of big asteroids and comets in the solar system at that time that are being accreted. And when you have an impact, you have a lot of material that is being ejected.
Right.
And orbital mechanics is such that when you have something that is ejected at high velocity enough from Mars or from the Earth, it would go and may end up on
becoming part of that planet,
and
I guess.
so they have been exchanging a lot of their material.
We're talking about a jillion years ago, right?
4 billion years ago.
4 billion, okay.
4.3, 4 billion years ago.
Okay.
And so we don't know yet. First, we don't know what is life still on Earth. We don't know how, you know, what is the transition between prebiotic chemistry and life. We don't know that. The sad news is that we will never know here. We'll never have a physical sample of that transition, because everything that is older than 4 billion years has been recycled by plate tectonics. It has been recycled by geology, erosion,
so
etc.
that original evidence is gone.
It's gone. We are getting evidence that is really old, 4.1 billion year old maybe, but, you know, get to a point where we are going to hit what I call the biological horizon, because that record is gone. But let's imagine for a moment that those two planets, Mars and the Earth, have exchanged material. You know, early on, it might be that the response to who we are, what is our origin, is sitting there on Mars.
Is on Mars.
Yeah.
Isn't that
because Mars doesn't have a plate tectonic.
Right.
And erosion and geological activity has been a lot less active.
How fascinating to think that the origin of life the answer could be on Mars.
To me, this is one, you know, of the most exciting prospects. And if life is on Mars, it can be from, you know, that planetary exchange, or it can be a different type of life.
Right.
So you can have
alien life of some sort.
Of some sort.
Okay.
Yeah. So that we know. But if we have to have family in the solar system, that has to be on Mars. If you are going outside what we call the inner solar system, which means Mars, the Earth, Venus, etc., towards the Sun, when you're getting to the outer solar system, Europa, you know, Jupiter, etc., celestial mechanics doesn't work that well. And so if something is out there, it has to be different, which is exciting too. That will be a different type of life.
Right.
But
I have to ask you, do you think there's life elsewhere?
You know, I can tell you I believe. That's not a very scientific statement, but having roamed the Earth where, you know, I have been, I still have to find a place where life isn't. And when you are looking at the environments and that we see on Europa, on Enceladus, on even on Pluto, can you imagine the geology on Pluto? I mean, so far away, so remote from the sun. So if I have to make a statement about my belief, I said yes.
Yes. And do they look like they have big heads with really big eyes?
Oh, well, you mean that kind of life. You mean not in the solar system,
right,
okay?
Right.
Not in the solar system. Advanced life, somewhere else.
Yeah.
Did Carl Sagan who said that it would be such a waste of space if we were the only one out there?
He did say that, right?
So, you know, it would be terrible to try to even paraphrase Carl Sagan. But he was very right when you are seeing the number of exoplanets that we are finding, you know, the number that can be in the habitable zone. Is it life as we know it? Not so sure, you know, but right now we're searching for life as we know it.
But if you had the chance to go now, would you hop on that rocket and shoot off to
On a round trip?
On a round trip?
Yes.
Not a one-way?
Not a one-way.
Yeah.
Not a one-way. But definitely on a round trip, I would be, you know, more than interested.
Yeah.
Then the first thing I would do would get Spirit unstuck from where it is in Gusev.
Oh, it's stuck right now. Okay, you got to save that little guy. Well, Nathalie, it's
became attached.
Of course you have, because you know he found something pretty amazing over there. Well, thank you so much for coming in. It's just fascinating work that you and other Mars explorers are working on. It's great stuff, and hopefully we'll learn more about ourselves.
I think this is, to me, this is one of the most exciting, you know, possibilities. Is that the answer to how it happened, you know, for us to be here, this time where prebiotic chemistry transitioned to biology. Might be sitting out there in an outcrop.
Amazing, amazing. Well, Nathalie, thank you so much.
You're very welcome.
Stuff. Well, in 2027, 4 people will allegedly head to Mars, the new frontier, and never come back. Now, a Filipino-American believes she has what it takes to live the rest of her days on Mars. Full Frame contributor Sandra Hughes caught up with California-based businesswoman Jamie Del Rosario to find out why she's ecstatic about being shortlisted for the possible one-way Mars One mission.
Bring in the sheets now.
Filipino-American Jamie Del Rosario is a Los Angeles-based CEO whose company supplies sheet metal to the aerospace industry. The 28-year-old is also studying mechanical engineering to get her degree. Oh, and she'd someday like to go to space.
Seeing my materials go from a processing aspect, from raw, first stage, to processing, and then going to space or going to being an end product, being used for technology or everyday use, I said, why not me? Hi, how are you?
All kidding aside, she's a hard-charging entrepreneur who knows what she wants and is often tapping new technology to enhance her own business. She's always looking to the future. That's what drew her to the Mars One project and the possibility of going to Mars, but never coming back.
Mars One will establish human settlement on Mars in 2023.
A Dutch entrepreneur is behind the Mars One project, which it says attracted 200,000 applicants. That number was whittled down to just 100, and Del Rosario is in that group. However, critics say far fewer actually applied. As for Del Rosario, she says she's glad she did.
It becomes an idea. They're doing everything that they can right now to all go to Mars, and I think it will be executed, and I want to be the first person to be there and to land there. And if it's not me, someone will, and I want to be able to help and assist.
There has been much exploration of the red planet by a robotic rover, and the U.S. National Aeronautics and Space Administration, or NASA, has found evidence that water once existed there, but no human has ever gone. The last human exploration in our solar system was to the moon back in the 1970s.
Different colors anyway.
And the International Space Station is continually manned with different astronauts and supplies. But Mars? Skeptics like University of California, Los Angeles professor David Page wonder how the project will raise funds and how this first so-called colony of Martians would live.
On Mars, you'd have to live inside an enclosed environment. You know, the atmosphere, you know, you wouldn't last more than a few seconds. It's just like in the movies with regards to, you know, the cold and the lack of oxygen and pressure in the atmosphere.
Commander, Mark is dead.
We have to go now.
Professor Page is talking about the latest Hollywood mission to Mars called The Martian. Actor Matt Damon plays an astronaut left behind on Mars to fend for himself in the hostile environment.
I'm still alive. Surprise.
Someone who actually goes to Mars will probably need to be selected very, very carefully and trained extremely rigorously and have, you know, backgrounds in all the sorts of things that they need to do. I mean, this, you know, the recent Martian movie sort of shows, you know, an example of a, you know, Mars survivor who has a lot of, you know, knowledge at his fingertips and is able to sort of put that to work.
Critics wonder how Mars One is going to pay for the project. The flight alone is going to be between 7 and 9 months. But what about building a colony 225 million kilometers away from Earth? A reality TV show showing the various candidates readying themselves for the journey was supposed to help pay for the project. But the status of that is still unclear.
Sending a human to Mars, I don't know, $100 billion, something like that. In today's money, maybe sending a colony, you know, many times that.
Mars One says it has investors and expects more. Jamie Del Rosario is realistic about her chances, but says she's ready for a one-way trip.
I am not coming back because it's, first of all, it's a permanent human settlement to colonize. Second is there's no launch pad. There's no Cape Canaveral in Mars yet. When our founding fathers found this land, did they say, you know, I think I'm going to go there and I'm going to come back?
While Del Rosario admits she'd miss her family, with no husband or kids, she says she's ready to take the trip of a lifetime. For Full Frame, this is Sandra Hughes in Los Angeles.
All right, we'll have to see what happens. We'll be right back with this week's Full Frame Close-Up. Stay right there.